question 4C has a typo. Obviously, if you have, if your hypothesis is that beta 1 equals 1, then your null better take care of all other possibilities, right? So that should say the null is that beta 1 is not equal to 1, rather than I think it says 0, which would make no sense. All right, so that's a typo in there. So it's 4C from 2008.
So that try one that you did, we just want to substitute the, when we have xi, we just substitute x bar in.
Where you, yeah, if you have the sum of xi, then you can substitute in x bar times n.
Okay.
And so, yeah, I mean, what you'll do is you'll kind of work through some of this and try to get the summation operator kind of isolated so that you have some of this stuff, here. Because you'll notice if you have, let's say, you have y squared times beta 1, right? You can pull the beta 1 out. So doing things like that just to get this, and then you know what beta 1 and beta 0 hats are. So just trying to isolate what we know in this value. It should come out pretty clean. Okay. Anything else on that? One other question that comes up is on question 5 on that same exam. Which is, it says to calculate the confidence interval for beta 1 minus beta 2. Okay, and I think there's a hint in there that looks for you to reparameterize the model. So we've done that a little bit before, right? So anytime we have a single hypothesis, we can always reparameterize to get what we're trying to test. And so here you can just set some placeholder equal to beta 1 minus beta 2. You can put A, you can put whatever you want there, okay? Just some placeholder. And the key is to then be able to substitute that in. So you can make this, right, so you could add beta 2 to both sides and get beta 1 equals phi plus beta 2. And then substitute this into here, right, like we would do when we reparameterize. So that should be what we get there. And then, so if you're looking to calculate a confidence interval, you could then, do a confidence interval. Your confidence interval is phi hat plus or minus, whatever the standard error of that value is, times some critical t value, which then if I gave you a, t distribution, you can look that up and know what that is. So you could, if you had phi hat in the standard error, you could calculate that confidence interval. Another thing you see coming up in both exams, and I think it's a very important topic, is the difference between a t-test and an f-test. Okay. So t-test, and I would say most of you feel pretty comfortable if I gave you a hypothesis of, beta 1 equals 5, and a null that is not equal to 5, you guys can do that pretty easily. Others might be something like this, right? If we had a hypothesis that beta 1 minus 2 equals 5. Again, you would do a t-test. Anytime you have a single hypothesis that you're looking to test, you're going to do a t-test. So anytime you see a single equals sign or a single relationship, you're going to do a t-test. And so t-test is usually to come, we reparameterize the model, we isolate this new variable, and then we can test it, right? We do just a typical t-test. F-test is anytime we have multiple hypotheses that we're jointly testing. So, for example, beta 1 and beta 2 both equal 0, right? Or beta 1 equals 3 and beta 0 equals 5, okay? So now anytime we have an F-test, we're going to want to come up with we already are going to have an unrestricted model, but we're also going to have a restricted model, right, that imposes the null hypothesis. So the restricted model is going to impose the null hypothesis, and then we're going to compare the results from the unrestricted and the restricted, either through R squared or sum of squared residuals, either one, okay? And so we calculate an F statistic, we compare that with the F distribution, and again, if I gave you a table of the F distribution for a particular alpha, you should be able to calculate the F statistic and then compare it to the value in the book, and then tell me if it's significant or not. Okay. So if we're going to do something like this over here, all right, so if we wanted to test this hypothesis right there, in this model, let's say, this would be our unrestricted model. Okay, so we run that, we get an R squared or sum of squared residuals, and then we compare that to the restricted model. So for that, what we're going to do is just substitute in what we have here in the null hypothesis. So beta 0 equals 5 plus beta 1 equals 3. Right, so this is our restricted model, but obviously we can't run this in SAS, right? SAS is going to have big problems if we say, make sure that beta 0 is equal to 5 and beta 1 is equal to 3. And so what we need to do is we need to get this in some kind of form that we can estimate in SAS. And so basically if we don't have something that we're estimating, we can move it to the left. Okay, so we can readjust our dependent variable. Right, and we can call this new value y star. And so the restricted model in this case is going to, right, so we create this new variable where we take y minus 5 minus 3 times x1 and get this new y star. And then we can use procreg, model y on x2 with no intercept. And then we get a restricted model. And then, from each of those, we either get an R squared or an SSR, and we can create an F-test. Okay? We know that as we go from the unrestricted to the restricted, we're taking away, parameter freedom. Right? We're saying that beta 0 is 5 and beta 1 is 3. And so anytime we go from the unrestricted to the restricted model, we're going to assume that the R squared is going to drop. Right? Because anytime we add variables, our R squared goes up. Here, essentially, we're taking away variables. So the question is that loss in R squared compensated for by the gain in degrees of freedom? So anytime we see a single hypothesis, t-test, multiple is always going to be an F-test. And so know how to do each one of those. You can see there's quite a few questions about those in there.